For express this fraction into partial fraction, as we can see, this quadratic factor, it cannot be factorized anymore, so it has to be split into the factor from quadratic factor. So one of the factor is linear, another factor is x squared plus 6. So linear factor up here will be constant, quadratic factor up here will be linear. Then we equal the denominator. For a, we have to multiply to the factor it don't have, which is x squared plus 6. So for this one, remember to put in bracket in order to avoid mistake. So the factor it don't have, it will be x plus 1. So the benefit in putting bracket, we can see this is bx plus c times with x plus 1. Without bracket, we will misunderstand that c only multiply with x plus 1. So it will give us a mistake here. So after we get this equation, we're going to let x 3 times. As we have 3 unknowns, so we have read it 3 times. So try to use the x from the factor. So such as x equals to -1. Substitute into our left hand side, you'll get 7. Then you get 7a. So a will equals to 1. Then continue, one of the x we can see x equals to 0, where you can eliminate b, you can find your c. So substitute x0. Here we get 0, 0 plus 1. So a already found it, which is 1 times 6. So for here, x is 0, so it will be c times 1. So finally, simplify, c is equal to 0. Then another x value, randomly we put 1, then we substitute. So here we have 7 equals to a is 1 times 7. And then b we don't know, b plus c, b plus 0, b, and then 1 plus 1 is 2. So here will be 10 equals to 2b. We found our b is 5. Then we rewrite our answer into our partial fractions. So as we can see, c is 0, so the numerator here we remaining have 5x only. Then we're going to integrate these partial fractions. We're going to integrate separately. So for this one, fraction form, we can use our formula number 6. So for this one, it's also in fraction form, but the denominator is not linear anymore, so you can use substitution method. So from here, I want to introduce another formula, which is the formula of integrate fx f prime x. It will give us ln fx. So which is the reverse process from differentiation, differentiate ln function. So as long as you can see fx is the denominator x squared plus 6, and then we found the differential f prime x will give 2x. So what we need here at numerator is 2x. So how do we solve here to get 2x? We can multiply, we factorize out. We factorize out number 5. Then we multiply with 2. So we multiply in with 2, we divide back 2, so that the question is equivalent back to 5x original. But we get the pattern, which is this is fx, this is f prime x. So to integrate this, we can straight away get ln to the function. So for this formula 6, ln to the denominator linear over coefficient x is 1. So for this one, 5 over 2, ln to the function, which is x squared plus 6, then plus c. simplify it. So for those that not familiar with this formula, we can use substitution to solve this integral. As we can see in formula 6, denominator is linear. When denominator is not linear, we can use substitution. Here I perform substitution method. So we will let u to be the denominator, x squared plus 6. Then we're going to differentiate u respect to x, we get 2x. So what we need to substitute here is x dx. So for x dx, we cross multiply. So the term x dx, it will be equal to 1 over 2 du. Therefore, we integrate 5, we factorize out. So 1 over u, where this x dx is represented, substitute by 1 over 2 du. So here, we factorize out our constant 1 over 2. We only integrate 1 over u du. So finally, integrate 1 over u, which is ln u. So lastly, we substitute back our term u here, which is u represented by x squared plus 6. So the answer still will give you to the same answer here, 5 over 2 ln modulus to the x squared plus 6.